Hey, top analyze math industry, and we are going to be proving the Pythagorean theorem. So, the Pythagorean theorem, as you probably know, is one of the fundamental theorems of geometry, and also it can help you with some algebra, but especially trigonometry. So, Pythagorean theorem was invented and founded by a mathematician named Archimedes or Archimedes. I don't know how you sound it, but we do know in fact that it is solved when you have a right triangle. Triangles that look like these. And when you do them, you have labels. We're going to say that this is A, and for over here, we're going to say this is B. And the last side is going to be C. So we can conclude that the formula is A squared plus B squared equals C squared. And yeah, A squared plus B squared equals C squared. And it's useful because when there's a right triangle, you find C, or the hypotenuse.
But it's so hot. Look, you're not allowed to change heads, alright? Now drop it. Get on my... But it's so hot. Look, you're not allowed to change heads, alright? Now drop it. Get on...
So let's try and solve one. Let's say this is 3, 4, and what is C? Well, A squared plus B squared is C squared. Then we'll have to say 3 squared plus 4 squared equals C squared. 3 times 3 is 9, plus 4 times 4 is 16. 9 plus 16 is 25. The square root of 25, because we have a C squared, that is going to give us C equals 5. So we have a 3, 4, 5 configuration. These are the most common triangles that you will see in a geometry problem. 3, 4, 5. If there's any triangles that are in proportional and also have a ratio to each other, then you can say that they're right triangles. But we'll save that video for later. What we're trying to do is, we already know what Pythagorean theorem is, and we reviewed how to do it. But how do we prove it? Simply. Well, did you know there are over 350 ways to prove Pythagorean theorem? But what we're going to show you is an easy way of visualizing it. How did we get A squared plus B squared equals C squared in the first place? Well, we are not going to review all 350. Did you know Albert Einstein invented his own way of proving this theorem? But how do we prove this theorem right here? As you notice, we have A's, B's, and C's, just like the ones in the formula over there. So when it comes to this, we have A's, which is here, B's, which is the other legs, this triangle and this triangle look the same. And we have a giant square, that's AB and AB. Because the area of a square is base times height, so that's why we say base times height. We have a smaller square inside of C. We have C, 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 C. And when we do base times height, C times C, we are going to get C squared. So let's see what happens. Let's try to do the math. We are going to say that we have A plus B squared, A plus B squared. And when we do that, that is going to cover the entire square. Now, what we're going to do is we have to somehow equal, if we do the base times the height of a square inside, the smaller square, you see that? Well, what's going to happen is we're going to say is equal to c squared. And that means that you will find the area of the smaller triangle, the smaller square, the one inside. But we are not done yet. What we still have to figure out is, if we draw another one on the piece of paper, we have to add that by another picture. And what's this picture going to be about? The fact that we have an empty space inside the smallest square. And we're going to say 4 multiplied by 1 over 2ab. And that is going to talk about the triangles surrounding the smaller square. But why do we do that? Well, what happened is, here's the proof, or here's the theorem. A plus b squared, because we had a plus b times a plus b, is going to be the same thing as saying we have this c squared that's shaded in right there, that square, plus the stuff that is surrounding the smaller square. So what's literally happening is, when you put that inside of that, when you put that thing inside of that, it's going to make a full square. So that's why we are going to say c squared plus 4 times 1/2 of ab is going to equal the same thing as a plus b, a full square. So let's try to solve this algebraically and see how we can get a squared plus b squared equals c squared right here. So we are going to say a plus b times a plus b, because the bigger square area, a plus b times a plus b. And that is going to equal c squared plus 4 1/2 ab. So here's how it's going to work. We have to simplify this to see how we get to a squared plus b squared equals c squared. Let's start. We can start by doing the distributive property. We can do a times a times b, and then we can say b times b, and b times a. When we get that, we get a squared plus ab plus ab plus b squared equals c squared plus 4 1/2 ab. Another thing we can do is we can pull it down to say 4 times 1/2 is going to be 2ab. So c squared plus 2ab. So here is the whole thing we've written down here. We can use the common like terms, combined like terms, ab and ab right there, because they have the same set of values or numbers or letters. So we can say a squared plus 2ab plus b squared equals c squared plus 2ab. We can now subtract this side. We can subtract this side by 2ab. Subtract this side by 2ab. And when we get to 0, guess what we're left with? We have a squared, plus b squared is going to bring us c squared. So that is how we can prove the Pythagorean theorem actually works. Because what we did is find the areas of the two squares and found the areas of the triangle, put that into an algebraic expression, and look what we got. This is the same as that. I hope this video has helped you understand proving Pythagorean theorem. Thank you for watching Top Penalized Math Industry. Like and subscribe.